Atomic masses and composition of nucleus. The mass of an atom is very small compared to a kilogram. 1 mole of carbon atom is equal to 6.022 into 10 raised to power 23 atoms of carbon, weighs only 12 gram. The mass of one carbon atom is 1.992647 into 10 raised to power minus 26 kg. Atomic masses are expressed in atomic mass unit. Atomic mass unit U is defined as 1/12 of the mass of the carbon, C12. 1 U is equal to 1.992647 into 10 raised to power minus 26 kg upon 12 is equal to 1.660539 into 10 raised to power minus 27 kg. Atomic masses are found with help of a mass spectrometer. The measurement of atomic masses revealed the existence of isotopes. Isotopes are atoms with the same number of protons but that have a different number of neutrons, such as C12 and C14. Isotopes of an element exhibit the same chemical properties but differ in mass. We can also say that isotopes are elements with the same atomic number but different mass numbers. Every chemical element has more than one isotope. For any element, one of the isotopes is more abundant in nature than any of the others, although often multiple isotopes of a single element are mixed. Chlorine, for example, has two isotopes having masses 34.98 U and 36.98 U. The relative abundances of these isotopes are 75.4 and 24.6% respectively. Thus, the average mass of a chlorine atom is found by the weighted average of the masses of the two isotopes, which is 75.4 into 34.98 plus 24.6 into 36.98 upon 100 is equal to 35.47 U. Hydrogen has three isotopes. The other two isotopes of hydrogen are called deuterium and tritium. They have the same atomic number or number of protons, number at the lower left of the element, but different atomic masses, number at the upper left of the element. The number of neutrons can be calculated by calculating the difference between the atomic mass and atomic number. We can see that for the isotopes of hydrogen, they have varying number of neutrons. For protium, the number of neutrons is 0. For deuterium, the number of neutrons is 1. And for tritium, the number of neutrons is 2. All the electrons of an atom revolve in different orbits outside the nucleus. The number of protons in the nucleus is called the atomic number Z. The number of neutrons, the neutron number, is represented by N. Mass number A is equal to Z plus N. In a neutral atom, the total charge of the atomic electrons is equal to minus Ze. the charge of the nucleus is plus Ze. The number of protons in the nucleus of the atom is equal to the atomic number Z. Discovery of neutron. In 1920, Ernest Rutherford postulated that there were neutral, massive particles in the nucleus of atoms. This assumption arose from the disparity between an element's atomic number and its atomic mass. This indicates that the nuclei of atoms contain, in addition to protons, neutral matter in multiples of a basic unit. In 1930, it was discovered that beryllium, when bombarded by alpha particles, emitted a very energetic stream of radiation. This stream was originally thought to be gamma radiation. Irene Curie and her husband discovered that when a beam of this radiation hit a substance rich in protons, for example paraffin, protons were knocked loose, which could be easily detected by a Geiger counter. Application of the principles of conservation of energy and momentum showed that the neutral radiation consists of a new type of neutral particles. In 1932, Chadwick proposed that this particle was Rutherford's neutron. 2He4 plus 4Be9 is equal to 6C12 plus 0N1. In 1935, he was awarded the Nobel Prize for his discovery. Chadwick was able to determine the mass of new particle as very nearly the same as mass of proton. The mass of a neutron is now known to a high degree of accuracy. It is Mn is equal to 1.00866 U is equal to 1.6749 into 10 raised to power minus 27 kg. A free neutron is unstable. It decays into a proton, an electron, and an antineutrino, another elementary particle. N gives proton plus minus 1 electron 0 plus nu antineutrino. It has a mean life of about 1000 seconds. It is, however, stable inside the nucleus. Nuclear species or nuclides are represented by the notation ZXA, where X is the chemical symbol of the species. For example, the nucleus of gold is denoted by 79Au197. It contains 197 nucleons, of which 79 are protons and the rest 118 are neutrons. The element gold has 32 isotopes ranging from A is equal to 173 to A is equal to 204. All nuclides with same mass number A are called isobars. For example, the nuclides 1H3 and 2He3 having the same mass number is equal to 3 are isobars. Nuclei nitrogen-14 and carbon-14 having the same mass number is equal to 14 are isobars. Nuclides with same neutron number N but different atomic number Z are called isotones. For example, mercury 198 and gold 197 are isotones. Both the species have 118 neutrons. Carbon-14 and oxygen 16 are isotones. Both have 8 neutrons.